So here we are, quadratic formula. Quadratic formula is great, right? It solves any quadratic equation. You've done it before. You remember, the formula. It's all over our classroom. Opposite of b plus or minus square root b squared minus 4ac all over 2a. And you might ask yourself, well, what's the a, what's the b, what's the c? The a is the number in front of x squared, the b is the number in front of x, and then the c is the constant term. So here, if I'm solving number 1, which can easily be factored, we know that, a is 1, b is negative 9, c is 14. So opposite of b means 9, opposite of negative 9, plus or minus negative 9 squared, which is 81, minus 4 times 1 times 14, all over 2 times 1. So 81 minus 56, I'm doing it in my head, 81 minus 56, isn't that 25? Which is nice because it's a perfect square, right? So 9 plus or minus 5 over 2. And you do have to separate that into two answers. One is 9 plus 5, which is 14 over 2, which is 7. 9 minus 5, which is 4 over 2, which is 2. R squared equals 3r. First you have to subtract 3r from both sides. So the a is 1, the b is negative 3, and the c is 0. So opposite of b here would be 3 plus or minus b squared. It's okay to write 9, right? And it's always going to be positive there. Minus 4ac, so that's just going to be 9, and 2a is just 2. So square root of 9 over 2. So 3 plus or minus 3 over 2. And now you can start doing some things in your head, like 6 over 2 is 3, and then negative 6 over 2 is negative 3. Oh, sorry. Negative 3, right. My bad. Going too fast. Negative 3 plus 3 would be 0 over 2 or 0, and then minus 3 would be negative 6 over 2 or negative 3. This one here, let's see, opposite of b would be 24 plus or minus square root of b squared. So negative 24 squared minus 4ac all over 2a. Now lucky for us, everything underneath the square root turns out to be 0. So we just have a double root situation here. So this is just 4/3. And really that's a double root, right? We want to recognize that, but it's fine. There, I guess you just can write it once. Let's see, negative 9 plus or minus, let's change colors. Negative 9 plus or minus square root of 81. Still not writing for me, there we go. Negative 9. Nope, doesn't want to. Let's try it again. There we go. Square root of 9 squared, 81. All over 2a, so that'll be all over 6. So this is our first one that doesn't really come out even. Square root of 105 over 6, we would just leave it like that. It's kind of nicer when it's not a perfect square, right? Here with 3x squared minus 4 equals 0, the a is 3, but the b is 0, and the c is negative 4. So 0 plus or minus square root of 0 minus 4 times 3 times negative 1 all over 6. So this is going to be plus or minus root 12 over 6, or plus or minus 2 root 3 over 6, or plus or minus root 3 over 3. Did I do that right? Perfect. Last one here. Oops. So this is going to be negative b plus or minus square root of 36 minus 4 times 7 times 2. So this is the first time, and 2a is going to be 14. This is the first time that we're going to see a negative number underneath the square root, negative 20. What's the square root of negative 20? Right, 2i root 5 over 14. And that can be simplified. I can pull a 2 out of the numerator, all over 14, and then cancel that with the 7. So my final answer is 3 plus or minus I root 5 over 7, and you have to take it all the way down to that. I'm sure you remember discriminant, but we'll go through it anyway. So the discriminant is the b squared minus 4ac. It's the part underneath the square root, the b squared minus 4ac. If the b squared minus 4ac is positive, that goes with this kind of graph where we get two real roots. What happens if the b squared minus 4ac under the square root is 0? Well, we saw that over in an earlier problem, right? Right up here. Yep. Yeah, number 3. And this one gives us 1 double root, which is, I should just say double root. It's really 2 roots, right? Just repeated. And in number 6, the b squared minus 4ac is negative. That's going to give us a floating graph and 2 imaginary or 2 complex roots. So sometimes I just ask you for the discriminant. Sometimes people wonder, is it before you take the square root or after you take the square root? It's before you take the square root. So here the discriminant would have been negative 20, or here it's 12, or here it's 105. It's the number under the square root. So I'm going to write that, the number under the square root. And that is it, quadratic formula. Boom.